Next up, we have Springfield, New Jersey, Team 1. It's a Mission 9 flight experiment.
Hi. We are from Springfield, New Jersey, located about 22 miles west of New York City. Our middle school has about 508 students from grades 6 through 8. Our experiment looked at the effects of microgravity on ryegrass seeds. Our seeds were sent to the ISS on February 19, 2017, and the seeds returned to Earth on March 19, 2017. Two of our teammates were able to watch the launch, Jeremy Dash and David Aries, and David is not here today. 8th grade team from FMG. Our team consists of Jeremy Dash, Daniel Munoz, Timothy Burns, and David Aries and Antonio Nachi were not able to attend the conference this year. Research. We were interested in understanding how microgravity affected the growth of ryegrass seeds. On Earth, seeds respond positively to gravity, so what happens to roots when gravity is very low? The test tube. We chose the type 3 FME tube, and the seeds were embedded in cotton gauze in volume 1. We were able to line them up so we could keep track of the 15 seeds. In volume 2 held water to start seed growth, and volume 3 held concentrated salt water, which was used as our fixative to stop the seed growth. Hypothesis. We were expecting the seeds to have similar growth in microgravity as on Earth because water is a primary signal to start the germination process.
On the ISS, we instructed astronauts to release the water to the seeds to start the germination process 9 days before the tube came back from the International Space Station. 5 days before the tube came back, we instructed the astronauts to release the salt solution as our fixative so we can see the changes. Our expected results. We expect to see the seeds to grow in different directions, and we were interested to see if there would be any changes in color or any other changes. Our results. The two graphs show the germination data for our experiment. The graph on your left shows the germination of the seeds in microgravity, and 2 out of the 15 seeds germinated on the International Space Station. On the right, the graph shows the data, and 8 out of the 15 seeds germinated on Earth. We were able to measure the root length of the seeds. Based on our measurements, the seeds in microgravity had longer roots, and on average the length was 2.6 centimeters, and on Earth the average length was 1.5 centimeters. As you can see, the seeds and the roots on the International Space Station.
All right, so shown in the graph are all the seeds that germinated on Earth, and the range of growth was 0.7 centimeters to 2.1 centimeters. We had several observations. First, we had germination in both labs, while the seeds sent to the ISS looked healthier. The seeds that remained on Earth had a darker color than the seeds that went up to the International Space Station. This experiment is important because growth in microgravity is good for future space exploration, and as our astronauts push the limits of where man can go in space in the future. If we could repeat our experiment and do something differently, we would decrease the number of seeds so there would be more space to grow. We would decrease the amount of water in one of the sections of the tube. We'd develop a better growth chamber for the seeds opposed to the cotton gauze. The gauze kept the seeds in place, but it was difficult to release the seeds once we were finished and measure our results. For acknowledgements, we'd like to point out a scientist who gave us some pointers on to use our salt fixative that helped the germination process of the seeds. And our funding sources came from our school district, Springfield Public Schools, and the Center for the Advancement of Science and Space. We also like to thank our teachers, our parents, and our school district for helping us.
Any questions for this team?
Hi, I'm Andrew from Buffalo, New York. So you guys saw, you've seen a bunch of presentations today, and you guys aren't the only ones who noticed that one of the plants that went into space looked more preserved than the other plants. What do you guys make of that?
I guess that the microgravity just has effect on the plant and the growth and just keeps it more preserved. Any other questions?
Thank you.